So, welcome everybody to our talk, Unlocking the Future of Kubernetes Policy as Code with Kyverno. So, I'm Frank, I'm a senior software engineer at Nirmata, and
I'm Vishal, and I'm a Kyverno maintainer. Yeah.
Let's start with the first topic, or our short agenda. So, first we talk about what Kyverno is for these folks who doesn't work with it yet. What it does today and how you can achieve your goals with it. Then we will go into the next features of our upcoming release, which will change the way Kyverno worked before a bit. And yeah, at the end, we're showcasing these new features with some demonstrations. And we prepared some stuff that you can try it out yourself if you like to. So let's getting started with what is Kyverno. Who of our audience already using it in some way?
Nice.
That's a lot, thank you. So what is Kyverno? Kyverno is a CNCF incubating project. The name comes from the Greek word to govern, which means basically governance. So it's a policy engine built for Kubernetes in a Kubernetes native way to help to achieve what your compliance or what your workloads needs to be compliant. Kubernetes native means that it only uses Kubernetes native logic or tools to write policies or it's basically relying only on YAML, so you don't need to write any other programming languages what is needed in other similar tools like OPA or Kubernetes, for example. So you only need YAML to achieve or to write your policies. It's working as an admission controller, so it already reviews and validates your workloads doing the admission review. It also works as a scanner, so you can validate resources which are already applied in a cluster. So when you have an already running cluster for a while and decide to introduce Kyverno, you can just run your policies in a background scanning manner and already check how your existing workloads are compliant with your given rule set. We're also providing features for auditing and reporting, so that you can see in an easy way how well your resources work with your current rule set. So why Kyverno? As I mentioned, as a Kubernetes native tool, it's easy to use. So folks which had no experience with other Kubernetes or policy engines in the past can easily start adopting it. We have a very large library of predefined policies for different use cases. We have a really active community, so with around 3,000 users in our Kyverno Slack channel, you get really fast help if you're stuck somehow. And nowadays we also support payloads outside of Kubernetes as long as it's based on a JSON format.
Okay. So let's talk about different features of Kyverno and what they can currently do for you. And this will also act as a summary of current Kyverno capabilities and use cases. So starting with validation. So validation, as the name suggests, validates a resource. So it's a standard yes or no policy where whenever you give this policy a resource, it will run the validation checks as you defined in the policy against the resource. It will give you a yes or no response, and you can do whatever you want based on the response that you get. So if you want to outright block the resource when it fails the policy, you can do that, or you can just create a report with all the results in it to use it for compliance reasons, right? This is the most common policy type that we have. It can be used for various cases like ensuring that a label is present on your resource, or something like the resource requirements like the CPU and memory limits are set properly. You can use it for that too. Currently, we support validation using patterns, which is a declarative way of specifying validation logic. So as you can see on the screen, there's an example where we're verifying that the label name is set properly on your resource. If you have a complicated condition, you can use our condition block, which uses James path and James path functions for writing complicated conditions. We also recently added support for cell, and we also support pod security policies. Besides this, you can also run background scans against your resources. So you can just periodically run those policies against all the resources in your cluster. It will create policy reports for you, and you will be aware of if every resource in the cluster is currently compliant with your standards. And this is great for time-proofing and preventing misconfiguration. Moving on. So as let's say in case you, instead of wanting to validate resource, you just want to mutate the resource, tweak it up a bit to meet your requirements. Instead of just blocking it, you can use a mutation policy. So as the name suggests, it will mutate the resource, and mutation always occurs before validation in the admission chain, which means that you cannot bypass any validation logic just by using mutation policy. Currently, we support both strategic merge patch and JSON patch. So strategic merge patch would be your declarative way of specifying how you want to mutate the resource. You can see an example on the screen where we are mutating the security context. And you can also just specify the patches directly using the patch, JSON patch format, right? You can just specify the operation path and value, it will do it for you. And even if you have installed Kyverno later after on a running cluster and you want to mutate resources that are already present in the cluster, you can do that using Kyverno as well. We also have support for mutating existing resources. Coming to the case where you'd want to, let's say, generate or create a new resource when a condition is fulfilled, you can do that using Kyverno generation policy. A use case for that would be, let's say you just created a new namespace and you want to ensure that that namespace has a network policy in it by default. You can do that using Kyverno generate policy. How you would define that? You can define the object you want to create using either you can specify a clone object, a source, which can be an object present in the cluster. So you can just use, let's say, an existing network policy as a source, or you can just directly define the YAML of the object you want to create in the cluster policy itself. And when you're using a source, Kyverno makes sure that the new object that is created is synchronized with the one you use as a source. So if you make any change in like the source resource, the clone resource will also have that change. So this is very good if you have a secret that you modify, and if every single secret that's created from that will also be modified. And it is good, it provides tamper resistance, and it is ideal for multi-tenant workloads. Next. A good use case that we have seen from the community is resource optimization, where you can create a policy which will match stateful sets and deployments. And whenever those are created, it will create a vertical pod autoscaler for them. And this is a policy that was used by Adidas to reduce the cost of running their cluster by 50%. And this was a major part of how they did that. Next. Okay. Coming to cleaning up resources, so we have this thing called a Kyverno cleanup policy, which will periodically look for resources in your cluster, and it will find them and clean them up for you on a regular basis. And this is like ideal for removing unused resources or resources that violate your conditions. We also support another behavior for cleanup where you can like set up a label called TTL. It's cleanup.kyverno.io/TTL, and you can, let's say, set that on a pod with a duration. So you can create a pod with a cleanup TTL label set to 1 day, and after 1 day, Kyverno will automatically like delete that resource for you. So this is also very good for setting expiration date on resources. One more use case for this would be to cleaning up pod disruption budgets. So sometimes what we have seen is that some pod disruption budgets, they do not get deleted, and sometimes they block nodes from being turned off, which can cause like extra cost. So what you can do is you can just create a cluster cleanup policy which will find those pod disruption budgets and automatically delete them, and help you in resource optimization. The last one would be image verification. So since Kubernetes is based on containers, so it is paramount that you only allow trusted containers in your cluster, right? And one way to do it would be to making sure that you only use trusted images, and you can do that by using image verification and signing logic. So you can verify images that were signed by either Notary and Cosign, both of the major image verification solution, and you can verify the signature on your container images. You can also verify the signatures on attestations like SBOM or vulnerability scan reports on those images. You can, let's say if you have a SBOM and you want to verify that it has the right licenses or like the right dependency, you can also do that using Kyverno. We allow you to check the payload object and make sure it has specific conditions on it. We support cosign, keyed, keyless, and certificates, and recently we also added support for the new GitHub artifact attestation. So these are all the Kyverno features, and you can use them for any compliance or security or automation use case you might have. So going on. Next.
So yeah, now that we know what Kyverno can do and what different types of policies we have, why do we want to change Kyverno in its way it's working today? So many of you might heard that Kubernetes nowadays has an inbuilt admission policy feature and provides an admission policy type for validating as well as mutating. And Kubernetes decided to go with cell as a solution to declare expressions for this kind of policy types. On the other hand, we have Kyverno, which also evolves over time and brings today many different ways to achieve the same or similar logic to declare how or what your policy should do. We have, for example, pattern matching as described, we have assertion trees, we have a basic cell support already, but this brings also some difficulties for us as a maintainer and for you as a user, because we're providing in the end one really large API and you have one single CRD for each type of policy. So you might not know what is the best solution for me. Should I go with James path? Should I maybe go with cell? Will pattern matching do the trick for me? It's really hard to decide, and also it's sometimes hard to know what fields or what configurations I need for my type of policy and how it will affect how my policy is executed in the cluster. For us as maintainers and also for the community to support, it's not easy to say you should go with one or another solution, as it's really depending on the user, on the environment, and on the scale. So let's take a deeper look on cell, what Kubernetes chose for their solution and what makes it different. So on the first point, we already have a really large feature set. We have memo features as James paths already without any custom extensions. We have a really large community which already provides a large library of different features you can easily add to your cell environment. This makes it really simple and powerful, and it is side effect free, so it doesn't mutate or change the input in any way. So Kyverno always had a goal to be cloud native as possible and to make it easy for you as a user to switch from other solutions or from the Kyverno admission validation policy to Kyverno to use the extended feature set. So it's more like natural that we now take a look on what Kubernetes does and how we could utilizing it to make Kyverno better for you as a user. And improvements we wanted to achieve as a list, we want to be simpler and expressive. We also use this as a chance to improve our performance, but also retain our current feature set. So it was not an option to go with cell now, but limiting the features Kyverno already provides to the user, because it doesn't help if the user has another way to write policies, but can no longer achieve what the user achieved before. And as mentioned, Kubernetes native, we decided to go with the standardized Kubernetes API as much as possible. So we basically reused the API for validation admission policies and just extended it with additional features Kyverno provides for you as a user. In the last releases, we left the Kubernetes space and are also be able to validate or in general operate on resources outside of Kubernetes. And we also want to keep this supported, and this means we have now one single API or CRD in case of validation, for example, to validate all kind of JSON-based payloads as well as your Kubernetes resources. So you no longer have to learn different things if you want to use Kyverno JSON for external resources, or if you stick to Kubernetes resources and use things like pattern matching. As mentioned, we want to keep our functionality. This means for us that we decided to extend the cell implementation we are using with our feature set and adding libraries that, implementing given features like resource lookups, external service calls, config map lookups, and other features you know from the existing API. And in the end, we have a better balance between be declarative and have an imperative syntax with the cell approach.
So based on the limitations that we just identified and the features that we want, we decided to create a brand new policy types. And these policy types will be simple and they're very expressive, and they will retain all the current Kyverno features, as well as we will add new features like support for any JSON payload, right? So here's what we did. We created 5 different policy types. So previously we only had one cluster policy, but we decided to split them into all of the 5 different rules that they have, which creates a very simpler API. And we created the validating policy, image validating policy, mutating policy, generating policy, and the cleanup policy. The first 2 will be available right now in 1.14 release, and the next 3 will be added in the future releases based on the feedback and what community wants. So let's get into the first one, the validating policy. If you look at the policy from the overview of the policy, it looks very similar to the Kubernetes VAP API, because that's the API we based this thing on. But if you look closely, you will see that we have added some small things like the evaluation config, and you will see an audit annotation at the bottom. So what we have basically done here is we have taken the VAP API and extended it with features that cannot be added in the API server and VAP because of performance constraints. So the features that we added can be, some of them are, let's say, if you want to make an API call to any external server, you cannot do it in the API server because they have time constraint, but you can do it here. You can use our own http.get library to make an API call. You can also fetch any resource that's present in the cluster. You could already do it in the cluster policy. That feature is also retained here. And let's say if you want to create a report and you want to make sure that the report has some custom properties, you can also add them using the audit annotation thing. So we still have the evaluation config. You can see in the spec.evaluation, you will see there's a background enabled true. So those things replicate the background scanning behavior that we previously had. And we also have the admission disabling. So every single thing that you know from current Kyverno will still be available in these, but we just created a simpler and like more expressive API. So talking about expressive API, we said that we would support JSON payload. So what we have done here is we have added support for JSON. So you can use the same API to create a policy that will be used, it will be able to use on any JSON payload. So what you have to do is you will have to just set the evaluation mode to JSON, and then you can just write any validation logic in cell. So in this example, we are basically verifying the JSON, the parsed JSON value of a Docker file, and we're running some checks on it to disable the use of curl command. Right? So you can do all of these with this API, the same API. You won't have to use Kyverno JSON or any different solution that we have. We just have one single API that will be able to satisfy all your needs in Kubernetes and outside of Kubernetes as well. So yep, based on the well-known Validating Admission Policy API, we extended it with Kyverno features that you already know and love. The policy boundaries have been made clearer by separating the policy into their own CRDs, and we have also added support for any JSON payload now. So the other policy that we're going to talk about here was the image validating policy. This is also based on the VAP API. So just like the VAP, it still has the validation block where you specify the expression, but if you look closely, you will see it has some special things. Like you will see there's an images variable here, and there's this thing called attesters, and there are functions that are not present in anywhere else. So we have added these things ourselves to facilitate image verification in these different type of policy, and so like we retain every single behavior that we currently had, and we added some more here as well. So one thing that we added for image verification was attesters. So attester is basically any trusted authority, right? So you can have an attestation of type notary or cosign. All the current cosign features like keyed, keyless, or KMS that you already know, they're already present here. You can also specify notary attester using notary certificates that you might create. And this variable you can specify these and then access them in the validation block, and you can run like cell expression on them to do image verification. Other features that we had to add was an image extraction logic, because we want to support image verification on any JSON payload. We will need your help to tell us where the images are, right? So if you have a generic JSON, you will have to tell us where the images are. And for that, what we have done is we have created an images variable. You can just specify the location of the images using cell, and we will find those images, and then you can access them to run image verification against them. You won't have to define these if you're using just a pod or pod controllers. They're auto-filled for you in those cases, but for any custom resource or JSON, you will have to specify these yourself. Attestations, as I previously discussed, it can be SBOMs or vulnerability scan reports. You can still use the cosign into attestation and the OCI referrers API attestation. You can define them in your policy and then they can refer to them in the validation block using cell. So here's a sample image validating policy. So you can see there's the attester block, there's an attestation block, and there's a verifications block. Since this policy only matches pods, you won't need to define the images variable here. And if you look at verifications block, you will see that there is a expression, and in the expression we are looping over all the images in the containers, and then we are using the verify image signature function, and we are verifying them against the notary attester that we have defined here, right? And the second one, once the first one passes, it will go to the second one, and it will verify the signatures on the vulnerability scans. And once that is done, then you can specify a condition that will find the payload of the vulnerability scan report, and then it will make sure that that payload doesn't have any critical or high vulnerability in it, right? So this gives you a more expressive syntax for writing complicated condition. You can write it on JSON now as well. So that's a very nifty feature that people wanted. And yeah, so as I said, we can add complex condition using cell. All the features from image verify image rules are already present, and now you can just use it on any JSON payload. So we will have other features like mutating policy and generate and other ones in the future releases. Right now we have these two, and you can try it out in the new 1.14 release. I think the RC for that is out already, and you will be able to access it there. So let's move to the demo.
So before I go strict into the demo, I prepared a QA code to a repository which has all the resources I will showcase in the demo, as well as links to the demonstration setups to our playground. So you will be able, without installing any RC or test build of Kyverno, to try it out and experiments with it. And yeah, every feedback will be very welcome. So let me quickly, I can show the QR code later again if anyone was not able to take a picture. So this is how the repository will look like. You have the different links to our playground. I will showcase this in a minute. So every demo we will presenting are here, and you can try it out and modify it. So let me start. So this is our playground where you can try things out. This is we already have a preview build for 1.13.40 where the new policy types are available. So as you already saw, this is a very basic, let me go with a validating policy, which checks a deployment label. So we're using a match condition to targeting deployments in this case. As in previous or for our current policy CRD, you can also just targeting pods, and we still auto-generate our rules for other controllers like replica set, deployment, stateful sets, and so on. So this feature will also be available for the new policy types, and you can still configure it over an annotation. And yeah, now we have a variable block where we basically using an env label from the resource we are getting and checking if the value is prod. And in the actual validation, we just checking if the value of the variable is true. If so, we will get a success. If not, we will get an error message. And on the right side, we see two example resources. So we have a deployment with the expected label on it, and we have a bad deployment with the wrong label on it. And you can run it, and as you might guess, the good deployment passed the evaluation, and the bad one provided our defined error message. So this is a very basic policy, and as I mentioned, we implemented different ways to re-implement the features Kyverno already had. One of them are the resource lookup. So we implemented a resource library which makes it possible for you to access other resources in your policy. So for this example, I have a simple config map with a single item. It's a list of namespaces I want to allow in my policy. And in the policy, we use a variable again to get config map from the default namespace and the given name of our config map. And in our validation, we can access this variable, the data, and splitting the list, so it converts from a string to a list. And then we check via the in operator if our namespace of the object is part of the list we defined in our config map or not. And also in this one, I have an example with a test, which was part of the config map list. And a second one, which is not part of the list. So, and also in this case, you see it's passing and failing as expected. And in our error message, in this case, I used a message expression. So you can also use cell in, for example, your message or audit annotations to dynamically access variables and values of your resource in the message. And yeah, in this case, we see that only the dev test and stage namespace is allowed, but in this case, we had a prod namespace. The last thing I want to show is also a helper function we are providing. In this case, it's the image data helper, so it parses your image string in your deployment pod, whatever, and you can do easily checks. For example, in this, we are checking that all containers in our pod have the GitHub container registry as its image registry. So when we have a deployment with GitHub registry, it should work. If we have one without, then it should fail. And also in this case, we see that the expected resource passes and the other one not. So yeah, these are my examples for the validating policy, and now we continue with some examples for the image validation policy.
Okay, so let's load a policy to verify image signatures. So you can see we have an image validating policy which matches on all the pods in the cluster, and then This is the match condition to verify that the prod is true. That doesn't matter here. And we are only verifying images that are present in the ghcr.io registry. So you can specify a glob or a set expression here if you only want to verify certain images on that resource. And in the attester section, which is the trusted authority, we are creating a notary attester. And we're passing a cert. The cert value will be verified against the signature on the image. And then, and then we are running some validation checks here. So in the validation check, what we are doing is we have an images variable, and we're checking all the images on the container. We are mapping against all of them. And then we are running the verify image signature. So this is the function that takes the image as the first argument and a list of attester you want to verify it against. And then in the return value, it will give you the count of attester that passed the image. So what we're doing here is we are passing the single attester that we had, and then we are checking that the value of the return value is more than 0. So one of the attester you provided verified the image. So if we run this, since this makes a network call, it might take some time. Let's see. Oh, quick. So this passed the image because we're using the signed one, and if I use the unsigned one, it failed because that one did not have a signature that can be verified against this policy. Nice. So that's the example for image verification. Now let's just look at attestation verification. So here we have a similar policy, but instead of verifying the image, we're verifying the SBOM attestation. So it is a referrer API attestation, which means it was attested to the image using the OCR referrers API. And what we are doing is we are using the verify attestation signature function. We're passing the image, we're passing the attestation, and then we're passing the array of attesters we want to verify it against. And we're doing the same thing. We're making sure that the value is greater than 0. And if we run it here, and if this passes because the image has the attestation. And quickly, let's look at one more. Here's one where you want to verify that the payload of the attestation is the right one. Again, similar policy, but we're just checking in the second condition that we're fetching the payload and verifying that the BOM format is set to cyclone.dx. And if you run it, this should pass. And if I just change it from cyclone.dx to say, yeah, done something. This fails because this is not the LBOM format that was defined in the payload, right? So these are the two policies that we have available at the moment. You can just try them out on the playground on the link that we have, which is where's this one, right?
This one.
Just give me a second. This should be here. Yeah. So you can just check out the examples in the repository that we have provided, and yeah, that's all we had to talk about. So do you have any questions?